Okay, welcome to lesson 1.2. Still working with parent functions and transformations. So this is day 2. In day 1, we looked at just identifying some of the transformations that were happening by either looking at an equation or looking at a graph. Today we're going to be given transformations and we're going to be asked to write the functions for them. So this is a little bit more difficult. It just requires you to really have an understanding of what does what. So when you see something in an equation, how does that affect, the the equation? And so it makes it a little bit more challenging here, but same idea of what we did yesterday, or last class. So if you remember, horizontal translations. So remember, I know this is kind of a bunch of math jargon here, but the point is, if we go down here to this, we remember, what this looks like, and we gave this to you last class. Remember that anything on the outside affects graphs vertically, and anything on the inside will affect it horizontally, where C moves it left and right, D moves it up and down. VA will either flip it over the x-axis if it's negative, or it could also stretch it and shrink it. I also told you not to worry about B. This is your horizontal stretching and shrinking. We don't really mess with that in this class. So we can skip B. So to go back up here, horizontal translation, so moving the graph horizontally, should be what's inside the parentheses, and that's what this means here, is that you're changing this horizontally. You do need to make sure that you remember that what is on the inside moves at the opposite of what it seems it would look like. Because the minus sign here, it's going to move it in the opposite direction. So when we see minus, minus h, when h is negative, you actually get it going the right, and if h is positive, then it ends up moving left, which is opposite the way you think it would be. So we have to keep that in mind. If this number in here is a negative, then it will go right, and then if it's positive, it will go left. Vertical translations, this is what this means. This is the outside, just like in the model I gave you. This is the vertical translation piece. So this is going to move it up and down. And because there's no minus sign here, you don't get this opposite effect. It goes whatever direction you would assume it would go. So a positive would go up and a negative would go down. Reflections. I mentioned this before. If you get a negative on the outside in that A spot, it will flip it over the x-axis. So here you have a normal line here, and if we make that negative, it now flips and goes the other way across that x-axis point. Reflections across the y-axis. This won't happen very often, but when it does, the negative will actually appear on the inside of the parentheses, and that is what we call a horizontal reflection. This is called a vertical reflection. Notice how it's on the outside. The outside is all the vertical stuff. And notice how your horizontal reflection is on the inside. Remember that everything that is horizontal occurs on the inside of the parentheses. So this is a horizontal reflection, meaning that it will flip over the y-axis. Now, the reason why this doesn't happen very often is because notice how it doesn't really change anything. It has the similar effect as it does over here. And when you deal with absolute values, because they are v's, when you flip them over the y-axis, they are essentially exactly the same, because if you take a v and you turn it sideways, it still looks like a v. So you don't run into this too often. Most of the time it's a reflection over the x-axis. Horizontal stretches and shrinks, we're not going to deal with that, so I'm going to skip it. Vertical stretches and shrinks, remember that this is that value that's on the outside of the parenthesis, this a value here. And so what that will do is it will stretch it or shrink it. If the stretch factor is greater than 1, then it's going to make it more vertical. It's going to make it steeper. If the a factor is a fraction or a decimal, or it's like, meaning it's less than 1, like 0.5, 3/4, 1/2, anything like that, then it's going to get more shallow. Okay, that's what this means. If it's between 0 and 1, less than 1 here, it's going to become more shallow, more flat. If it is greater than 1, you'll see it become more steep. Okay. And so here we go. Here's the modeling that the model that I gave you guys. And so this is what you just have to remember. Okay, what affects, if there's something in this spot, what does it do? If there's something in this spot, what does it do? If there's something in this spot, what does it do? Also, keep in mind that every graph looks a little bit different. So with lines, when we have just regular lines, we don't even have B and C. Okay, if it's linear, then you don't even have the horizontal stuff. You just have the vertical stuff. And with absolute values, these are bars instead of parentheses, but it's the same thing. And next unit, when we get to quadratics, this will essentially be the same thing. There'll just be a square there, but it all follows the same sort of model. So when we look at stuff like this, so this is an example here where we give you the function and we give you the transformation, and you are asked to write the function for this. So you have to ask yourself, what does this do? What letter would it affect? Okay, a translation of 2 units to the left. Okay, you have to ask yourself, what moves it left? Well, we have right here, C is what moves it left or right. So I know that I'm going to impact C. Now with my function here, there would be an A on the outside. There's not really an A. You have a B. It doesn't look like there's a C, and it doesn't look like there's a D. So A would go right here, C would go in here, and D would go on the outside. But I don't have an A, C, or a D. But I do have something here that affects C. So 2 units to the left, you have to remember that with C, C's the weird one, C moves opposite in the way that you think it would. So if you think that 2 units to the left might be -2, it's actually +2. So our new function, which we can call g of x, is going to be the same exact thing. The only thing is now we're going to have that 2 units left, so I'm going to have a +2 on the inside. So this right here is that 2 units to the left. And that's essentially what you're going to do for each of these problems. So here in number 2, we have a translation of 6 units down. Let's change colors just so we have differences here. Translation of 6 units down. Well, you have to ask yourself, okay, well, what affects down? Okay, well, okay, then that's this right here, D. Now, I do have here, change these all to blue. I do have an A. I don't have a B. I have a C, and I have a D. So I do need to affect this right here by shifting it down 6. Now, one thing you have to understand here is, it's already down 1, so if we're going to move it down 6, then you're going to move it 6 more down. So this will actually turn into -7. So everything else will stay exactly the same, x plus 9, but now this is -7. So you'll see here that that has been a transformation of 6 units down. Again, that's what we do every single time. Again, here, so with 3, you have a linear function here. So with linear functions, you only have A and D. So here's, let's keep with the thing here and change the colors. Oops. So we don't have B or C. We don't have the horizontal stuff. So you really have just A and D. I have a translation of 7 units down. Again, just like the previous problem. It is D that it's affecting. So I know that this number right here has to go down 7. So you just ask yourself, what is 2 minus 7? And that is -5. So my new function, which I didn't even write these in the previous one, but g of x equals, everything else will stay the same. We're just moving it down 7, so -5. And that is your down 7. Reflections across the x-axis are vertical reflections. And since we have just a line here, there is no horizontal, so it's simply going to be a reflection across the x-axis just makes it negative on the outside. So it's just as simple as that. Our new function would just be -1/2 x plus 8. And that's it. And then here, reflection across the y-axis. Again, if it's across, so a reflection across the y-axis is a horizontal reflection. So that negative has to go on the inside. If it were vertical reflection, it would go on the outside out here. I did it twice. Let's change colors. It would go on the outside. But since it's a horizontal reflection, the negative just goes on the inside. It's pretty simple. So our new function would be absolute value of -x plus 1 and then plus 4. Nothing else changes. You'll see these start to get a little bit more, so like vertical stretching by a factor of 4. This is another one that's really easy. Vertical stretch by a factor of 4. Vertical stretch is, oh my gosh, is your A. So here's where A would go right there. So a vertical stretch by a factor of 4 just simply puts a 4 there. And x plus 3, and then plus 2. And a vertical shrink by a factor of 2. And this is kind of worded weird, because usually we say vertical shrink by a factor of 1/2. Instead of 2. We don't have vertical shrinking when the factor is greater than 1. So when you see, you're not going to, I should say you're not going to see that. If you see a vertical shrink, it's always going to be like that. It's always going to be a fraction of some sort. So that should be 1/2. So all we need to do here is take this out front here and multiply it by 1/2. So it would be 2x plus 2 would be our new function. Okay. Now, let's get a bunch of them going at the same time. So we're going to start off here in this last question. We're going to start off with just the basic f of x equals x. So what I'm going to do here is I'm going to, let's change back to green. I'm going to write f of x equals, now I'm going to just spread this out. So here's my a, here's my b, there's the x, here's my c, except it's minus, and then here's my d. Same thing. So when you have a bunch of things changing here, you're going to have to change multiple things at the same time. So it says write a function g, I guess I should change this to g, whose graph represents the reflection in the y-axis, or sorry, in the x-axis. A reflection across the x-axis is a vertical reflection. So I know that I'm going to affect this one right here, followed by a vertical stretch by a factor of 3. I'm going to do this one again. And a translation of 5 units down. So 5 units down is D. So it looks like I don't have a B and a C, so I don't have to worry about that. But I do have multiple things done to A. First of all, since it's a reflection across the x-axis, it's going to be negative. Because it's a vertical stretch by a factor of 3, a 3 will go here. I don't have a B or a C, so the x will just be there. And then translation of 5 units down would make this minus 5. And that would be the equation of that transformed graph. So again, it's a little bit more challenging. This is something that certainly takes practice in order to get better at. So make sure you're working through the practice on big ideas and ask questions if you're confused at all. But hopefully that helps, and see you in the next